Welcome back to Boiler Wild, episode 83. We are in August 2026, just winding down the end of the month, and it is going to start getting a little bit colder. But if you're a real boiler person, you've been busy all through the summer. Being a real boiler person, I don't want to offend the people who do other work such as, the general HVAC work or chiller work. You are still loved if you listen to this podcast, but the real boiler people will know that a lot of boilers get opened up during the summer. There's a lot of boiler maintenance during the summer because I talk to a lot of people. Well, I don't want to exaggerate. It's not a lot, but whenever I talk to people, they'll say like, "Oh, what do you do during the warm months for boiler work?" Because boilers aren't needed. And yes, boilers are not needed for the heating, but the people who are real in depth with the boiler work are either servicing heating boilers, heating systems, and or installing heating boilers during the summer, or they're working on process boilers, which don't know what the temperature is outside and are running 24/7 unless they are down, and they will run right through the summer. Typically, companies don't care with the process boiler what the temperature is outside. Sometimes the process boilers will also pick up the load for some heating, maybe some heating on the shipping docks. I've seen some steam coils with fans on them for shipping docks for the winter, but that is just a minor load versus the actual process load of the plant. But we are going to be entering September pretty soon, and it'll start getting colder, and hopefully you are ready for primetime boiler season, and hopefully your customers are too, because we all know people love to wait till the first cold, the first frost, and then they go in their boiler room, or they wonder why their boilers don't work correctly. But, they walk in the boiler room and they see the boilers are apart or they're off or not working. And they go, "Oh, right. We told them to get us through the winter last spring. And then we shut these down in May and told ourselves that we had till September. And it's now September. Oh, yeah. Hopefully they can get us that part real quick." Then you have a bunch of people calling at the same time, and all of a sudden you're super busy. And then they wonder why you can't get out there the same day and have the part the same day. And even if you ordered the part the same day, manufacturers, for some reason, there seems to be this lax on stocking parts. It has become normal to not stock parts. Lead times have become normal. And I don't want to go into why I think that is, because I don't know exactly why it is. So I would just be guessing. But there are still shortages here and there of random parts, and that always makes it hard for the companies that are servicing boilers, because now you look like the bad person. And that is why, if you are an end user, you need to be stocking parts that are critical, and you also need to be ordering parts or ordering service and doing projects ahead of time and scheduling ahead of time. This is not the 1980s or 90s where you can get somebody out the same week and they have just, your boiler has a couple random boiler parts on it, and most boilers have those same parts, and then you just go down to your local supply house, get the parts, come back and change out. Boilers nowadays are a little bit more complicated, and they require a couple bit more parts that are not always stocked at your local supply house. So anyways, I'm excited for September, October, November. Not that my business changes too much because I don't service boilers, but I'm excited to see everybody starting up boiler systems, to start getting into some hoodie weather, and hopefully you're prepared too. Let me know what you do for preparation. If you want to email me, eric.johnson@boilerin.com, or DM me on LinkedIn. If you're on LinkedIn, we haven't connected yet, please connect with me. Love to hear from you. I love talking to people who are working in the boiler industry or any other industry that is similar. Even if you're an operator and you just take care of the boiler at your plant and you're listening, I love to hear from you. I love to hear people's experiences. It helps me get a better worldview of what is going on and what the world needs for training, education, and maybe some different problems to solve. So today we're going to talk about the 5 ways to control steam pressure in a boiler. And this is going to be a steam boiler. Hopefully you're not making steam in a hydronic boiler. If you are operating your boiler very incorrectly, and you should get that checked out. But the 5 ways to control steam pressure in a boiler, and you may be, if you're a little bit more experienced, you may be checking them off in your head, and you're like, 5? Man, what are the 5? Yes, there are 5 ways to do this. And I'm going to, right off the bat, say that this is going to be for a boiler with parallel positioning or electronic control system. I guess you could do like a PLC. It's going to be kind of the same thing. But most boilers that are in the market that I like to work around are parallel positioning. I still love the linkage boilers. I will talk about those, but the linkage boilers will actually only have 4 ways to control steam pressure because of how they are typically wired up and ran, and they don't have multiple brains in them. They only have the flame safeguard. So let's get into it. If you have any questions, once again, reach out to me. If you haven't already, please rate the podcast 5 stars. It costs you nothing, but helps me immensely. Helps other people find this podcast. Share this podcast with your coworkers. I'm not a big self-promoter and marketing person, trying to get more into it, but if you just say, hey, I learned something from this podcast, and if you tell me that and tell your coworkers that, tell them to listen, it helps me out so much. It energizes me every time somebody reaches out and says, hey, I love the podcast. Because sometimes I just feel like I'm shouting out into the void, but that is all right. Here for love of the game. There are 5 ways to control steam pressure in a boiler. The first one is going to be your modulation, and that is going to be, this is often misunderstood, but the modulation of steam pressure is the changing of the fuel input rate in order to achieve a steam pressure. And that steam pressure is going to be your desired steam pressure set point, and that is what you are going to want in your boiler. It depends on how your system is ran, but let's just say that we don't have a big pressure drop across your non-return valves. This is going to be what you want in your plant. So in your steam header, if you want 100 PSI, you're going to want your boiler to run at 100 PSI, and that's assuming that there's not a huge pressure drop across your non-return gate valves and your spool piece. So we're just going to assume that the boiler drum pressure is also 100 PSI. That is not correct in all cases, but you may need like a plant master controller in order to make that run correctly. But we're just talking simple boiler steam systems. If you don't already know, a steam header is a large collector pipe that multiple boilers feed into, and then on the outlets of the pipe, it goes to all the loads. So that is a collection of steam from all the boilers and helps even out all the boiler loads so that the load is not concentrated on one boiler or the other. If everything is evenly divided, the steam header should be where all the steam pulls from, and it should equally pull from all the boilers. So the modulating steam pressure set point is the set point in your steam boiler that it's going to change the fuel. And think of this as your gas pedal of your car. If you want to go faster, you press down the gas pedal. If you want to slow down, you pull up on the gas pedal. Same thing with your steam boiler. If you need more steam pressure, that's going to be more fuel. So it's going to add more fuel. And we're talking about fuel, typically natural gas, could be propane, could be fuel oil. With electric boilers, this works a little bit differently. It'll bring on elements and turn off elements depending on how many elements you have. So if you have 10 elements, it will click on maybe 5 elements. And then if it needs more, it'll click on a couple more elements, and then maybe all the way up to 10 elements if the boiler is really far from the steam pressure. And then as it gets closer to the steam pressure, it'll start turning off the elements, but it is not going to essentially modulate the electricity to the elements. It is just going to be turning on the elements on and off. And out of the 10 in that example, it is going to be modulating how many are active and powered. I'm going to mostly reference fuel boilers because a lot of people use fuel boilers as in natural gas. So modulating is your gas pedal, just like your car. Once again, more fuel is more steam pressure because we have more heat going into the boiler, which is going to boil more water, which is going to make more steam. If we reduce heat into the boiler and if we reduce it down to the minimum firing rate, we will be at the minimum amount of heat input to the boiler. We will be still making steam, but if the load has increased above that minimum point, now we'll need to add more fuel to balance everything out, and we're trying to balance everything at 100 psi in the boiler or in the header. And when your plant goes to, say, zero load at the end of the day, or it gets warm outside and you don't need any more heating, your minimum load will fall below the minimum or turn down of your boiler. Turn down of your burner is essentially the minimum heat input that the burner can handle. Not every burner is infinite turn down. I don't think any of them are infinite turn down, but 5-to-1 is super common. Typically up to 10-to-1 turn down on burners is sold for steam boilers. If you have a 10-to-1, that is on the higher end. But 5-to-1 is your average burner. Sometimes they can be 3-to-1. So if you have a heat input that is 10 million BTUs and you have a 10-to-1 turn down, your minimum fire would be a 1 million BTUs to keep the math simple. So low fire would be 1 million BTUs input and high fire would be 10 million BTUs input, 10-to-1 turn down. Same thing with all the other ones, 5-to-1, 3-to-1. It's the same math problem. So if the steam load or if the load falls below the minimum fire rate or minimum turn down of the boiler, the modulation control can only take the boiler burner down to its minimum position, which is going to be X amount of heat input. And if the steam pressure keeps rising, the second way to control steam pressure in a steam boiler is going to be your electronic operation control. And this is, once again, going to be on parallel positioning systems or PLC systems with a brain beyond a flame safeguard. And this is going to be your electronic operation control, and that is going to be inside the settings of your parallel positioning controller, and that is going to shut down the boiler. I will also note your modulation control is going to be inside the settings of your electronic control, your parallel positioning system. And by parallel positioning system, I'm talking about like a FireEye Nexus system, Siemens LMV5, AutoFlame, Mark 8, Mark 9. Those are parallel positioning systems. And the settings are going to be inside the systems. And that is going to be opposite of a traditional boiler. A traditional boiler with linkage, and I'll say traditional steam boiler, you will have 3 pressure controls on your control tree. Typically, they're going to be Honeywell pressure controls. Pressure controls, once again, is a trademark name and a standard name, just like Kleenex and tissue. Kleenex is a trademark name. Honeywell has trademarked the name pressure control, although that is a standard name used in the industry. But you're going to have 3 physical controls on your steam header tree that is going to control your steam pressure. And the 2 of those 3 are going to be your physical modulation control and your physical operating control. Typically, that modulation control will be a 0 to 135 ohm coil that is going to drive a mod motor or a Honeywell Module 4 motor that is going to have the 0 to 135 control in it. And then the second one will be the operating control, which will just be a pressure switch that is going to be single pull, single throw, and is going to open as the steam pressure rises above the set point of that control. However, with a parallel positioning system or a PLC system, wherever you want to call it, or whatever you have on your boiler, you will have the operating control, your first operating control, and your modulating control. Those will just be settings inside of the electronic control system, your parallel positioning system, and your parallel positioning system will know what the steam pressure is in your boiler from a pressure transducer that is on the control tree of the boiler. So that is how that knows. If you look up on your control tree and see a little cylinder-like object that is probably 3 to 4 inches tall, maybe 2 inches in diameter, that is probably your pressure transducer, and it'll have some wires coming off of it. And if you trace the wires back, that will go to your parallel positioning system. So that is how your parallel positioning systems knows what the steam pressure is inside the boiler. Going back to the electronic operator, that is going to be when the boiler shuts down. So if we have the minimum fire rate turned all the way down and we are at minimum fire and the steam pressure keeps rising inside the boiler, we can't infinitely just keep rising up on the steam pressure. So say our set point is going to be 100 psi. We're going to have 150 psi MAWP of a boiler. That is going to be maximum allowable working pressure in the boiler. However, we don't want to raise our steam pressure all the way up to 150. And we actually can't due to all the safety controls on the boiler. But say our plant can handle up to 110 psi. So we're going to maintain with our modulation control 100 psi. If the boiler pressure drops below 100, the modulation control will add fuel. If it rises above 100, the modulation control will take away fuel until it's at its minimum firing rate. If the boiler steam pressure keeps increasing up to 110 psi, and once again, these are just examples, if it keeps increasing up to 110 psi, the electronic operator we have set for 10 psi over our modulating steam set point, or the set point we want to maintain. Sometimes people get that confused. They think an operating control, that's where you're going to operate your steam boiler. That is just what the boiler control is called, the operating control, but that is not where your steam pressure is going to live on how these systems work. So a modulating steam pressure control is actually where the boiler is going to operate and try to maintain that steam pressure. But the steam pressure keeps rising up and it hits 110. And then our electronic operator says, hey, we're 10 psi above our modulating steam pressure. We are at 110. All right, we're good. Cut it out. And it's going to turn off the boiler. The boiler is going to go to post purge and then to standby. And depending on what the load is, the steam pressure may quickly drop or it may just slowly drop, but the steam pressure will slowly drop and then there'll be a cut in. This will be different than the cut out. The cut out will be 110. The cut in, we may say, is 5 psi differential. So it's going to be 105. So the steam pressure will hit 110. The boiler is going to shut off and then it'll go 109, 108, 107, 106, 105. And then the boiler starts. It'll go from standby to pre-purge. And then when the boiler lights, hopefully it's around 100 psi. So the boiler doesn't have to do this big catch up. And then it'll just maintain and modulate to 100 psi. And then once again, if it repeats that cycle, as most plants do, if they don't have a steady state load, or if they're in a low period of load, the boiler will eventually rise up to 110 and shut down. There is no limit to how high you can make that steam pressure. Just know that every part in your system needs to be rated for it. So if you have parts in a steam system that are only good to 125 psi, you obviously can't go above 125 psi. But in a 150 psi boiler, typically I would recommend all your parts be good for 150 psi. There is some issues with that if you have 125 psi parts and you have a 150 psi boiler. I would always recommend having 125 psi safety valves. That's a side tangent. So the operator, shut it down, and I will say that is the electronic operator. If you have a linkage control, that is going to be the physical operator. So the third way to control the steam pressure is going to be your physical operator on your boiler. And this is going to be the third one. And this is different than a linkage boiler because a linkage boiler doesn't have the electronic operator They have a physical modulator and they have a physical operator. But even with all our safety controls, ASME requires a physical operator to be present. So even though your parallel positioning system or your PLC system is turning the boiler on and off with your internal operating set point measured with a pressure transducer, ASME still says, hey, you still need a physical operating control. So you're going to have a physical operating control that is set just higher than your electronic operator. So in this example, if we're modulating to 100 psi and the electronic operator is set at 110 psi, we may set our physical operator to 115 psi. And that will allow us or keep the boiler safe if somebody changes the electronic operator, but that will allow us a little bit of a room for the electronic control system to work properly, just in case it overshoots a little bit, that it's not turning off on the physical operator. But if we have a little bit of space in there, that is fine. If we don't, we can back it down to 112 if you really ran up against the safety valves. There's no requirement of the space in between the electronic operator and the physical operator. And that physical operator is going to be on the pressure control tree. And it's typically going to be a Honeywell pressure troll or a Danfoss. The white controls, I forget the model number. I don't know if they have a trade name, but I know Cleaver Brooks likes to use the Danfoss ones. Fulton likes to use the Danfoss, but or the Mercoid. Mercoid was bought by Dwyer. You can use the Mercoid. Mercoids, they're a little bit weird. They seem super complicated and they're kind of big, but you can also use the Mercoid. Or I've also seen, I think it's Ashcroft. Ashcroft? Yeah, the black, I think it's Ashcroft. They're black pressure switches. I've also seen those. Although those, they are not super great with being able to set a precise set point with a scale. Typically, you have to bench test them and bench set them. But really, I've only seen those used on larger water tube boilers. They are a little bit more durable control. They also come in like explosion proof or fully waterproof housings. You can get that option, but the set point control on them is not going to be as fine as you can see on a Honeywell pressure troll, but they still work, but you would just have to set them on the bench, pump them up with a calibrator and make sure that they are set correctly, and then write down where the control is going to trip. But you can use any of those, but that is going to be your physical operating control. And then the fourth way to control steam pressure on a boiler is going to be your high steam pressure control set point. And ASME, once again, mandates 2 steam pressure controls on a boiler, even if you have an electronic operating system. So we're going to have 2 physical steam pressure controls. We're going to have 1 physical operator. In this case, that is going to be set at 115. Then we're going to have a physical high steam pressure control, and that is going to be set higher than the operator. So in this case, let's set it at 125 just to make sure it doesn't trip, just in case we overshoot our operators for some reason, or if we're playing around with our set points and our steam set point goes up by a little bit, we don't want to have to move our high steam pressure control set point. And that high steam pressure control will differ than the operator in that it will be a manual reset. And I know CSD1 off the top of my head. I don't know NFPA, but it has to be a manual reset. And CSD1 says the manual reset can be inside or part of the control. So on a Honeywell pressure troll, on the new ones, it'll have that little red button on the front. You'll press that little red button. The Danfoss, the white housing controls will have a green slide on the top right of the control, and you'll push that green slide back. Mercoid pressure switches will have the reset at about the 5 o'clock position on the side of the housing. So you'll press a little metal rod in and it'll reset the control. So those are some different controls for the high steam pressure limit. Also, the manual reset can be part of the control system. So it doesn't have to be part of the control. That is a common misconception. So if you want to have an automatic high limit, as long as your control system locks out and requires a manual reset, that is also good for CSD1. I am not sure on NFPA. I am not as well studied off the top of my head for NFPA on that. And that would be NFPA 85. If you want to look it up and let me know, but I'll probably look it up after this recording just so that I can get educated, because I know this will seem crazy, but I don't know everything, and I'm not afraid to admit that I don't know everything. I am just here trying to spread what I know, what I've learned, so that you can be better and help others learn as well. So going back, so the modulation control controls the amount of fuel or the amount of heat input into the boiler. In this example, we're modulating to control 100 PSI. That is going to be our steam set point. That is what our plant requires, 100 PSI. That's what we're going to set our modulation control to, not our operator control. If we set our operating control to 100 PSI, the boiler will get up to 100 and cycle and turn off, and will never maintain 100 PSI. So every time we hit set point, we'll be right there and then cycle and turn off. And then by the time the boiler turns back on, the steam pressure will have dropped, and it'll be this cycle. And if you were to look at the steam pressure, it'd never be consistent. But I have seen pressure controls set up like that by people who didn't know better. They thought, oh, operating control, that's where we want to operate. No, actually the operating control is going to be where the boiler is going to actually shut off, and it's going to be your highest safe operating steam pressure for the boiler. But typically that is going to be set about 10 PSI above the modulating pressure control. So in this case, the electronic operating steam pressure control is going to be set at 110. And then ASME requires we have a physical operating steam pressure control, which is going to be on our control tree. That is, in this example, going to be set at 115 PSI. And then ASME also says that we have to have a manual reset high limit pressure control that is physical as well. And that is also going to be on our pressure control tree. And we are going to set that at 125 PSI in this example. And that is the only control that is manual reset. So if that trips, it requires an operator to go in and either press the manual reset on the front of the panel or press the manual reset on the control. I always recommend having a manual reset on the control so that no matter how the boiler is wired, you will always know that your high limit tripped, and you have to push it on the high limit and actually look at the high limit, because some operators will just push reset on the front of the panel, and sometimes you don't have the best air history, or sometimes the boiler is not wired in a way that you will know that the high limit tripped. So if you have all, or not all of them, but if you have a couple limits that are wired in series and you don't have any way to distinguish between the limits, anywhere in that limit string, if it opens, the boiler is going to turn off and fail, but you as an operator won't exactly know what is in that limit. You'll have to check each and every control. So you'll have to pull out a wiring diagram. Hopefully you have a wiring diagram, and you'll have to see what is in that control string. And then eventually you'll find that the high limit control is open. But if it is open and it has a manual reset on it, you can hear the click when you push the manual reset, and then the boiler will start, and you'll know that it was the high limit pressure control. And then you can take the appropriate action when diagnosing the high steam pressure control and why it tripped. So the fifth way to control steam pressure on a boiler is going to be your safety valves. Safety valve is the proper term for vapor service, not relief valves. It is going to be safety valves. So use the term safety valve. That is intentional. Relief valves are for liquid service. So that's going to be on a hot water boiler. So a steam boiler has safety valves. There is a difference. Look it up, ASME. Safety valves are going to be set anywhere at the MAWP of a boiler or less. I know they can change a little bit, but typically, depending on the jurisdiction, they will be set differently, or they'll be set the same. I'm not going to go into that. We're just going to assume that safety valves are going to be set the same. So if we have two safety valves on our boiler and the boiler has a MAWP of 150 PSI, we can order our safety valves to have the same pressure, set pressure as the MAWP of our boiler. So both safety valves will be set at 150 PSI. So if our modulating steam pressure control doesn't control the steam pressure inside the boiler, if our electronic steam pressure control doesn't shut off the boiler, if our physical operating control doesn't shut off the steam pressure or the heat input to the boiler, if our high limit doesn't shut off the steam pressure or heat input to the boiler, if all those fail, and they can, that seems wild to some people, but they can due to how they're piped. It's a very easy failure point. But if all four of those don't work, now you have our safety valves. And our safety valves are sized on our boiler in order to exceed the capacity of the boiler. So if we have a certain amount of heat input, that heat input will then translate to a certain amount of steaming capacity for the pressure vessel. And that steaming capacity will be less than the amount of steam that can be relieved out of the safety valves. Over a certain size of boiler, you need 2 safety valves or multiple safety valves. So you'll see some boilers have 1 safety valve on them, and then you'll see some boilers have 2, or other boilers will have 3. There is a certain size of boiler where the manufacturer is required to install 2 safety valves versus 1 larger safety valve. But the total combined capacity of both of those safety valves has to be greater than the capacity of the boiler. How do we know what the capacity of the boiler is? So every boiler has a ASME marking or ASME stamping data on it, and your boiler will be stamped with an ASME designator. That designator for a high pressure steam boiler, which is 15 PSI or more, is going to be typically on a normal boiler, it's going to be S. So that is the most common one. If you have a heating boiler, which is going to be 15 PSI or down, that is going to be stamped with the designator H. But next to that ASME information will be the rated capacity of the boiler, and that will just be a number as in pounds of hour of steam. So say it is 7,000 pounds an hour of steam. Your total capacity of your safety valves would have to add up and exceed the 7,000 pounds an hour of steam. So if you had a safety valve that was set at 4,000 pounds an hour of steam relieving capacity, on the safety valve tag, it will say capacity, and it'll say 4,000 pounds an hour. And if you have 2 safety valves, the total capacity of both the safety valves would be 8,000 pounds an hour, which is greater than the total capacity of the boiler, which is, in this example, 7,000 pounds an hour, and therefore it would be compliant. So that is something that you got to look at on every single boiler. Typically, it's going to be correct. Typically, if you have more than 1 safety valve, they are with a little bit of margin over capacity of what the boiler actually produces. Very rarely have I seen 2 safety valves add up and be like at the exact, just over the exact capacity of what the boiler does. Typically, since you can't exactly match safety valves perfectly to the boiler and there's really no need to do it, the capacity is going to be much greater than what you actually need. I wouldn't say much greater, but 10 to 20% easy, greater than what you actually need. So let's go back through these top to bottom. We went bottom up. Let's go top to bottom. The MAWP of a boiler is going to be the maximum allowable working pressure of the boiler. Typically, your safety valves will be set at the MAWP, but they can also be set less than the MAWP. If you have an MAWP of 150 PSI, you can have your safety valve set at 125 PSI. That is fine. You just cannot have your safety valve set higher than the MAWP of the boiler. In general, I know there's some exceptions with the 10% or 5% over with the modulation or changing of the set points of the safety valves, but in general, the safety valve set point will be no higher than the MAWP of the boiler. The next one down will be your high steam pressure limit. That is going to be a manual reset limit, and that is going to be a physical limit that is going to be on your control tree of your steam boiler. That physical limit will be the last line of defense before your safety valve opens and relieves steam pressure from the boiler, but that high limit is going to shut down the boiler and hopefully make it safe if all the other limits before it do not turn off the boiler. Next, below the high limit is going to be your physical operating steam pressure control switch. That is going to be the physical switch right next to the high limit on the control tree. That physical switch will be set just under the high limit steam pressure control. So if your high limit steam pressure control is set at 135, your operating steam pressure control would be set at 130. That is going to shut down the boiler. Your operating steam pressure control is going to shut down the boiler if your electronic operating steam pressure control doesn't shut it down. We're going to be talking about parallel position control boilers or PLC control boilers. They'll all have electronic operating pressure control settings that will shut off the burner, and that will be inside the controller. And the settings of the cut on, cut off, that'll be all inside the controller, but you'll have that electronic operating control. That is important to remember, because if you are thinking that you're going to be cycling the boiler on the physical operating steam pressure control, you will have the boiler short cycle because that control is opening, and the electronic brain, the operation, the parallel position control of the PLC is not going to be expecting that control to open if its own internal set point for its operating control is set higher than the other operating control. So you'll have short cycling of the boiler, and it won't seem like there's an issue, but there will be an issue to somebody who is keen on how a boiler should be running. And then just below the electronic operator is going to be the electronic modulation control. The modulation control is your gas pedal of your car. More fuel is more steam, less fuel is less steam. So that is going to modulate the amount of fuel input or the amount of heat input into the boiler, which is going to try to maintain the amount of steam pressure that you need in your boiler or in your header. So in our example, if we're trying to maintain 100 PSI, we're going to be setting our modulation control to 100 PSI. And if the steam pressure rises above 100 PSI, we are going to be in the low fire position. If the steam pressure drops below 100 PSI, we're going to be increasing fuel proportionally in order to try to make up the steam pressure and make more steam pressure and then get back to the set point of 100 PSI. And if we keep rising above that because the load is low, then in our example, the electronic operator will shut down the boiler at 110. And if that operator doesn't shut down the boiler, say the pressure transducer pigtail is plugged or something's wrong with it, then the physical operating steam pressure control is going to shut down the boiler, and that will be set at, say, 115 in our example. And then after that, the next safety is the manual reset high limit. Once again, the high limit doesn't have to have the manual reset as part of the switch. It just has to cause a manual reset function, but I would highly recommend it be part of the switch. It just makes troubleshooting easier. Also makes identifying the control easier. Without it, it will look just like the operating steam pressure control, and then you'll have to look at the wiring diagram and trace it back to see which one you should be setting higher as far as the set point, although you could also trip it and see which one causes an alarm versus which one will just shut down the boiler and cause it to go to standby. The operating steam pressure control, I should have said this earlier, will just shut down the boiler and cause it to go to standby, where the high steam pressure control will cause it to go into alarm, because the thinking is if the high steam pressure control, if that fails, or if the high steam pressure control is operating and shuts off the boiler, something is wrong because the operating steam pressure control below it, and if you have, in this case, the electronic operating steam pressure control below that as well, if those two controls have not shut off the boiler, something is wrong, and we want a operator to come look at it. So that is why a manual reset is required. So those are the 5 steam pressures. Hopefully you do not walk in and find the boiler cycling on the safety valves like I have. That was a good experience. The customer called and said, hey, our safety valves are periodically blowing on our boiler. And I went in and it was, I won't even say the boiler manufacturer, but this one, not a good design of boiler. But basically the whole control tree stemmed around a little nipple that never got inspected, never got cleaned, just due to how the boiler design was. And the nipple was 100% plugged, which then removed the sensing from all the controls. And this was a little 1/4 inch nipple, not, it was definitely a choke point in the boiler design. Should not have a little 1/4 inch nipple that is then feeding all the pressure control tree piping. But due to this boiler design, that was how it is. I haven't seen that on any other boiler design, but that plugged up and it jumped out all the controls. So none of the safety controls were seeing boiler pressure. So the boiler was sitting in high fire, and the safety valves would run up to the safety valves, and then it would blow the safety valves, and they would eventually blow down the boiler to where the valves would shut, and then it would just keep opening the safety valves, and it was essentially just cycling on the safety valves. That made for a very long and interesting day. The customer was very, very confused as what was happening, and I was also confused as to what was happening because I had never seen a boiler cycle on the safety valves. But that is just a great example of the safety valves working and none of the electronic steam pressure controls working due to that design. And that is why when you are opening up a steam boiler and maybe doing an inspection on a steam boiler, that you should be taking apart the control tree piping, that you should be visually looking through it. That is why we put crosses on the piping. That is why we put T's on the piping, so that we can see down through the piping so that there are no plugs. Even if the piping is 90% blocked, it would pass a pressure test, as in like pressure can get through, but we obviously don't want to close up piping that is 90% blocked because it is going to eventually become 100% blocked. So we're going to want to visually see any blockages, and you will also want to, I know it takes time and your customers don't have the time, they need production back, but you will want to pull apart all the pigtails and flush those and inspect those. That is well worth it. And I would also highly recommend, depending on the amount of steam pressure you have, you got to be mindful of your steam pressure, but having pigtails that are not carbon steel, having ones that are brass is highly recommended because they won't corrode on the inside. Like the steel ones, I've seen steel pigtails, they will corrode and it'll almost become a pinhole right below the steam pressure control switch. And then eventually when that pinhole blocks up, sometimes it'll block up when you shut down the boiler, because that's the first time that the boiler's been shut down. But when that pinhole blocks up, now that control is essentially isolated from the boiler. And depending on how it blocks up, it'll either trap pressure in between the control and the pigtail, or it'll trap no pressure in between the control and the pigtail. And I've seen it both ways, to where a control won't reset because of that, or I've seen it where the control will not run. I've had another issue where the control tree piping was 100% plugged, and this was a little bit special application on this boiler, but the control tree piping was plugged, and I was starting up the boiler, and I found it interesting that when I was firing it, that the pressure gauge or anything didn't seem to be going up yet. I was making heat, but it was open to the header, so I was like, man, must be consuming a lot of steam pressure. And then all of a sudden the boiler shut down, and it shut down because the high limit steam pressure control was piped off a different pipe, and that shut it down. But on my gauge, I was still at 0 on the steam pressure. I was like, oh, why'd the boiler shut off? And then I find that the high limit steam pressure control had tripped. And then I got to looking into it, and I found out the entire control tree was 100% plugged, But luckily, the high steam pressure control was piped on a different pipe off of that particular boiler, and that is what shut down the boiler. Otherwise, I would have found out that all the pressure controls didn't work and were blocked from the safety valves opening, which would have been no big deal. That is why ASME has safety valve sizing and the rating of the safety valves, and that's why safety valves have ASME designators on them, the V. And you have to be a certified rebuild shop. Those are calibrated safety valves and everything. So there is a lot of safety controls that go into a boiler. Boilers are very safe when they are operated correctly. But as a service technician, as an operator, if you are pulling apart a boiler, you need to make sure that you are making sure that you are setting those controls up for success, and that when you close that boiler together, that boiler can run for another 365 days without having any issues. If you have partial blockage and you close it up, yeah, it may be fine for a week. Yeah, it may be fine for a couple months. But if it's partially being blocked, and we're just going to assume that blockage is going to keep building, and that's going to become a service call and a problem with that plant operation. And we will always want to prevent that. And that is part of the preventative maintenance from the inspection standpoint. When you are taking apart a boiler on its annual, that you are cleaning all the piping, that you're looking at it, that you're either cleaning or replacing the pigtails, that you're doing everything you can to make sure that you're giving that boiler the greatest chance of running correctly without any problems for a year. So that's what I have for you today. The 5 ways to control steam pressure on a boiler. Hopefully you learned something. If you didn't, maybe I failed you. Maybe it was just review. If you have a positive review, please write that. I think, I've had some people comment on Spotify, but write the positive review, 5 stars on Apple or Spotify or Amazon Music or iHeartRadio if you're listening on those, but or even YouTube. But I appreciate everybody who listens to this podcast. And if you have any questions, guest recommendations, or anything else, you can reach out, eric.johnson@boilearn.com, or DM me on LinkedIn. Thank you for listening, and stay wild.